Okay, so this is lesson 1.4 where we're going to be solving inequalities. Now, honestly, 99% of what we do here at the beginning is the same as solving with an equal sign. The difference with the inequalities is that they have the inequality signs. We're not talking about things that are equal to each other. We're talking about them being less than, in this case, less than or equal to, greater than, or equal to. So we're talking about a comparison between the two as opposed to them being dead on equal. Okay, so I'm going to solve same as I normally do. I'm going to move my 5 over, get that x by itself. It's almost there, but not quite. Now here's our one difference. If I divide by a negative, a lot of times people remember this. Anyone remember? You divide by a negative, you flip that inequality sign. Now, it doesn't happen very often, but also if you happen to multiply by a negative, you still flip that inequality sign. So here then is our answer. We're going to graph these on number lines. So if I were to graph this, x is greater than or equal to -1. So it's greater than or equal to, I'm going to use a closed circle, and greater than, I'm going to shade in this direction. Okay, let's look at one or two more of these. Okay, so here is my inequality. I'm going to go through and solve. Now, I've told y'all this before. I personally like to keep my x's positive, so I'm going to choose to move my 2 over to this side so that I get 4x. While I'm at it, I'm going to get the 6 out of the way. So I have 4x is greater than 8. Divide by that 4 to get the x by itself. X is greater than 2. Okay, so here's 2. If it's just greater than, I'm going to use an open circle and shade where it's greater than. Okay, so going through to solve here, I've got to make sure I do my distributing and combining like terms first. So I'm going to distribute each of these. Just bring down that -20. Distribute out the 8. I'm going to combine my like terms. And then basically I'm back to where I was before. So I'm going to group my x's together. So I've got 2x. While I'm at it, get that 24 out of the way. So over here, I have 8. And then divide by that 2. Now, one negative to me personally, liking to keep that x negative or positive, is that sometimes in an inequality it sort of ends up on the wrong side. So I'm going to turn this around to put my x first, which means I'm going to keep the little side by the x, big side by the 4. So my answer is x is less than 4. So 0, here's 4. If it's less than, no equal to, so open circle and shade where it's less than. Okay, last one before we look at a few other things. I'm going to distribute out my 2. And I'm going to group my x's on the same side of the equal sign. Now here's where I'm going to run into problems. If you look at this, the problem I run into is that my 2x cancels here, but it also cancels there. Here's what I have left. Now normally I'd move things to different sides of the equal sign. I'm just going to stop right here because I want us to talk about this. Here's what I have left. Looking at this, -3 is greater than -10. That's true, right? -3 is greater than -10. If I were to do it on a number line, here's -3, here's -10. It's true. It is bigger. In this situation, you're going to have one of two situations. See if you buy this logic. It doesn't matter what the x is. It cancels out anyway, and always leaves me with something that's true. always, my answer is the whole number line here. It always leaves me with something that's true. If you were to write out your answer, you could tell me all real numbers. It's the whole number line. Now let's talk about this for a second. Let's just say that this was not true. If this was not true, think about what the answer would be for a second. I can't ask you what you think, but I'm going to tell you, see if you guessed right. It means that there's no solution. So if this is something that's false, that's not true, then your answer would be no solution. Okay, now I want us to look at a couple of word problems with these. One of them is a multiple choice. Kind of reminds me a little bit of SAT-like things. And on here, I want us to write an equation, or it's going to be an inequality. I want us to write something to go through and solve. So here's what they tell us. A salesperson earns a salary of $700 per month plus 2% of sales. What must sales be if the salesperson is to have a monthly income of at least $1,800? So it's got to be his sales, or his income, has to be greater than or equal to $1,800. He's fine if he makes more money, but he needs to make at least $1,800. Okay, so let's go through and let's write our inequality. We'll write this side of it. So he makes $700 per month plus 2%, so there's 2%, of whatever he sells. That's what I'm going to call X as his sales. There's my inequality. So let's go through and solve for it, for his sales. So subtract off my 700, and then I'll divide by my little tiny bitty decimal. Now I want to ask y'all to do this without a calculator, so if you use your calculator, that's great. So X has to be greater than or equal to 55,000. Now looking at this, I'm pretty sure it has to be this. Let's read it. At least 55,000, which is the same thing as greater than or equal to 55,000. So answer C. Okay, one more of these. Let me go ahead and put a little rectangle here to represent our picture. Okay, so here's our question. The length of a picture frame is 3 inches greater than the width. The perimeter is less than 52 inches. Describe the dimension of the frame. Okay, so let me go through and put in here the things that we know. I'm going to call the width W. And then this is what they tell me about the length. It's 3 inches greater than the width. So I'm going to call the length W plus 3. Okay, now when I add all of these up, I do the perimeter, it needs to be less than 52 inches. So I can do that. I have my two widths, so 1, 2W, and I've got 2 of these W plus 3s. Alright, do my number crunching, distribute out, combine like terms, and then solve this thing. So 4W is less than, not mean to put that equals 2 there, is less than 46. So when I divide by my 4, W is less than 11 and a half. Okay, now if I add 3 onto my 11 and a half to get the length has to be less than 14 and a half. So here then are my 2 parts of my answer. Okay, now we've looked at some different types of inequalities. The last thing that we're going to do in this section 1.4 is we're going to look at something called compound inequalities. Now, if we're talking about compound inequalities, what you're looking at is where there's two. Now, I want us to look at two situations. I want us to look at the typical AND situation, and I want us to look at the typical OR situation. Then I want us to make sure we see kind of a weird OR situation as well. Now what I'm going to do is I'm going to graph both of these. I'm going to put them in different colors. I'll put this first one in blue. So I'm going to divide by 2. So x is greater than negative 5. I'll graph that in a second. And I'm going to put this second one in red. So x is less than 2, and we're talking about AND here. Okay, so if I go through and I graph this, here's my 0. I'm going to go ahead and put negative 5 and 2 on my numbers. Okay, if I'm graphing this where x is greater than negative 5, it would be an open circle and then shaded this way. Now, if I'm looking for where x is less than 2, it would be an open circle, and I probably should have done this below, an open circle and shaded this way. Now, if you're talking about and this is true if you're just speaking about the word and in general, you're talking about and, you mean both. If I say you and I are going to chapel today, that means both of us are going. Whereas if I say you or I are going to chapel today, that means one of the two, but probably not both. So what we're looking for here is where both of my things are true. Both of my inequalities are true, which is this part right here in the middle. See how I have both of them? Over here, I've got the red one, but not the blue one. Over here, I have the blue one, but I don't have any values on the red one. So let me go through and put this in, and I'm just going to put it in black so that it's a separate color. So I'm going to leave this one open because right here I don't have a value on the blue one, but I do on the red one, so that's not both of them. Same thing here. I'm going to leave it open there because I don't have a value on the red one. I do on the blue one. And here's where I have a value on both of my problems. It's where they overlap. That's what you're talking about with the and, is you're looking for where they overlap. Typically, it looks like this, where they're overlapping in the middle. Okay, I'm running a little bit short on time, so we need to do the second one quickly. So I'm going to go through and I'm going to solve x is less than 4, or x is greater than 12. Now, if you're talking about or, same thing about you or I are going to chapel. It means one or the other, but not both. So that's what you're looking for. Now, I'm going to graph each of these. So here I am at 4. There's 12. Now, this is less than. At 12, it's greater than. Now, see how these don't overlap? That's the typical situation that you have with the or thing, is they don't overlap. So both of these are parts of your answer. Now let's look at one more or one, and then that's where we're going to end. So here it's or. Same thing. I'm going to solve these quickly because we are running a little bit short on time, or YouTube will not like my video when I upload it. Now here I'm dividing by a negative, so I'm going to flip my inequality sign. Okay, now I'm going to graph these. So here's negative 4, here's negative 8. So I'm going to put the first one in red, this one in red. So here it's greater than or equal to, no it's not or equal to, it's just greater than negative 4. So there we go. Okay, second one I'm going to put in black, so negative 8, it's greater than or equal to. Now I want you to look at this. This is or. So we're looking where I only have one of the two. I've got one of the two going on right there. That is my answer. So my answer is x is greater than -8, but less than or equal to -4. See how that one's kind of weird?